Hello. Well, excellent. Well done. You made it through the time vortex or whatever with me. So, we are in ancient Greece, 2,100 years ago. Why are we in ancient Greece? Well, we're here to talk about how you would tune a musical instrument if you didn't have access to all the modern things.
All them modern things.
All of these sort of precision equipments and instruments and devices that we can do to use to measure frequencies in the hundreds of hertz, all these things that we can use to measure seconds, all these things that we can use to look at things that are vibrating very quickly and things that are very thin and all that sort of stuff. They didn't have all that. They didn't have guitars or pianos or trumpets or anything like that. They had lyres. I mean, that wasn't the only instrument they had, but we're going to talk about the lyre in ancient Greece. Obviously, before there was music theory, there was music. People for who knows how long had been making up music and singing songs with pitched notes and playing instruments made out of all sorts of things and making notes for them. And normally, what would happen throughout the majority of the evolution of humanity is you would learn music from whoever there was near you who was doing music, and you would hear it and you would learn it by ear and you would repeat it as best you could, and that's how music happened and evolved. And by the time we get to ancient Greece, writing has been invented, and people in ancient Greece are doing a lot of kind of philosophizing. They're thinking a lot about how things work and what's going on, and they're trying to write a lot of stuff down, trying to write down basic principles of stuff. There's a group of people called the Pythagoreans. They absolutely love whole number ratios between integers, which they think are completely sacred and absolutely fundamental to the running of the cosmos. They are spectacularly wrong about this, it turns out, and it turns out that you can prove that all sorts of important numbers, even numbers that were known about in ancient Greece, such as pi and the square root of 2 and phi, the golden ratio, and the exponential number e, are all irrational numbers. But, luckily for us, they were on something when it comes to musical harmony. Now, I was going to use a lyre to demonstrate this, but it turns out I'm fresh out of lyres. Went to my lyre cupboard a little while ago and I found out I haven't got any left. Just used the last one up a while ago. I didn't think about replacing it. And then, of course, now, what with the situation, everyone's stocked up on lyres. I went to the shop, can't get one for love nor money. So I'm going to use the closest thing I've got to a lyre. I'm going to use a guitar, which, like a lyre, has got strings that are fixed at both ends, right? Okay, so let's say you're in ancient Greece and you want to tell someone else how to tune an instrument and they can't come to your house and hear you play your lyre. They have to read something that you've written. They might be miles away. They might not have a chance to ever get to see you. They might live in a different era. They might be living after you're dead. But you still want to be able to tell them how to tune their lyre. Unfortunately, you can't tell them how to tune the first note. Let's choose a first note. That's a note. That'll do. You can't tell them where to put that first note, but you can say something about where to put the other notes relative to that note. Okay, so I'm going to mimic lyre playing here as best I can, which means I'm not allowed to use any of these frets. Guitars have got frets and a fingerboard, and lyres didn't have that. It's just a string fixed at both ends. So I'm not going to do anything that involves the fretboard. That would be cheating. What I am going to do is I'm going to play you this note on this string, and then I'm going to put my finger about exactly halfway down the string. I'm just going to touch the string. I'm not going to fret the note, promise. I'm just going to touch the string, even take my finger away after it to prove it, and I've got another note. There's a note, there's another note. Now, that's what we were talking about before. That's an octave. That's such a sort of harmonious interval that it's considered to be another version of the same note. Nevertheless, we can take our note and we can tune another string to that. Let's tune this string. Well, there you go. That string. Oh, actually. Let's do it the other way around. I'm going to tune it. There you go. I'm going to tune it so that string, that's better. I'd rather tune strings down than up, otherwise I'm going to be breaking things. Okay, so we've got two notes. We've got a string tuned to a note, and we've got a string tuned to the octave of that note, which is on the first harmonic. And we could do it again, couldn't we? We could take that string and we could tune another note to the octave of that note. Do it by ear, really? Great. That's a start. And we've got notes we go. We've got notes that we can play together if we're accompanying some lyric poetry, which is what Lyres were partly for. Get a bit of atmosphere going, but it's still not really a very useful scale of musical notes. We can't get much out of it by way of melody and harmony. You can play the riff from Immigrant Song by Led Zeppelin, but you can't go to any of the other chords or do the melody. Luckily, so this harmonic is called, right, when you have a string like this, it's fixed at both ends, and each of these ends has got a point which is called a node. A point of no displacement. Node displacement. Do you see what they did there? It's very clever. And what I did here was I put a third node, another node, right in the middle of the string. So I forced it to sort of split into two strings. They're connected to each other, obviously, but the string can't move here. Now, when I play this note, it's got a main frequency, which is the frequency, a fundamental frequency, which is the frequency the string vibrates at across its whole length. But it's also vibrating all these harmonics that are vibrating across different proportions of the length. So I'm splitting this one here, and I'm isolating only the harmonics here where nothing moves in the middle. And the main frequency of this note, being with me splitting the string into half its length, is double the frequency. So I can say this octave is double the frequency, and then therefore this one up here is going to be double, which is 4 times the frequency. And I've got octaves, that's nice. But I can also play a harmonic here, a third of the way down the string, and likewise I can get a frequency, twice the frequency, a third of the 3 times the frequency, a third of the length. I could tune a string to that. Whoop. There you go. And now I've got this string and that string and that string and that string, and I could even tune one in between these. Like these are copies of our original note, right? And I've got one in between those. I could have one between these two by taking this one and saying, well, if an octave is twice the frequency, then an octave below is half the frequency. Then I can tune something so that its octave is there. And I've got this set of notes, which is good. I can do some stuff here. I could get some stuff happening, but not so much melodies, and you can't do chord changes and stuff like that. Okay, so we get a harmonic there halfway up the string, we had a harmonic there a third of the way up the string, is there 1/4 of the way up the string? Yes, but we've already got that note because it's 4 times the frequency, it's 2 times 2, we've already got one there. What about one at a fifth? Yep, there is. And we could tune a note, so I'm not going to tune a note all that high because I'll break strings, but I can tune something to an octave below that note. There, and I can get, so that's note, get this lovely major chord. Isn't that delightful? It's beginnings of some music going on here, but the Pythagoreans didn't do that. The Pythagoreans did this harmonic, and they did this harmonic. I might not have done that one, it's the same as twice this one. They didn't make it as far as this one. For whatever reason, they did not use the fourth harmonic, the one that's at the fifth of the way up the string. They didn't use that. So we don't have that string, it's gone. All sorts of possible reasons for it. One of them could be to do with the fact that 2 and 3 were more important to them, and they thought these was blah, blah, blah. It's a religious thing. I mean, I don't know. The other reason is actually quite hard to play this harmonic. So this harmonic's easy to play. This harmonic's easy to play. This harmonic's not so easy to play. This harmonic gets a little bit difficult. You have to start paying attention to your picking technique. And as you play up the strings, the higher ones, it gets really quite hard to manage to get a decent note out of it. It's very quiet. So maybe it's just that ancient Greek lyre strings being made of actual animal guts and stuff, probably not quite as accurate, not as even in thickness along the whole length, not as reliable, and maybe you just can't get a decent harmonic out of them. These strings are made of nylon and they're wound with clever things in factories designed to produce the best tone. Didn't have that in the old days. So we're going to have to abandon the guitar because the Pythagoreans didn't use that method, and because we're going to start tuning to all sorts of other notes, and I'm not going to muck around with the strings too much. Let me just put it back in standard tuning. Roughly. that's close enough for jazz. Right, we're going to have to sacrifice the guitar to Zeus.
Oh, thank you very much.
And move to the virtual lyre. The what? The virtual lyre. Look, here it is. Woomph! Crikey, that's big. So, the virtual lyre. What we're going to do here is, this is a line of frequencies, okay? So we're going to talk about the frequency of a note. And again, we don't know exactly what frequency we're starting with. It doesn't matter. That 1, that's where we're starting. That's arbitrary. Whatever our frequency is 1 times that frequency. So I'm going to start with this note. This is my first note. And because I'm going to produce a list of different notes, I want to label them. I can't really use the numbers 1, 2, 3 and so on, because they're not going to come out to be the first, second, third and fourth and so on notes of a scale. And that would be confusing because we're going to use those numbers a lot later. Be misleading. So, also I can't use letters. Normally if you can't use numbers, you use letters A, B and C, but then that's what notes are actually called, so that's going to go wrong as well. So I'm going to use, because we're in ancient Greece, I'm going to use Greek letters. This note I'm going to call alpha, and I'm going to put it at 1. That's 1 times our main frequency. Doesn't matter if you don't know Greek letters. It's also colour-coded, and you'll be able to see it on the whole thing. It's just an arbitrary way of labelling things. So we know there's an alpha there. We know there's an octave of alpha at 2, twice that frequency. We know there's another one at 4 times that frequency, which is 2 times 2. We know there's another one at 8 times, 2 times 2 times 2. And there'll be one at 16 and so on. We also know, because it's all doubling, that if we halve it, that's 1, that's a half. We also get one octave at half, and one at a quarter, and one at an eighth, and so on. Okay, right. So that's where we're going to put our first notes, and these are all notes of alpha. And like we say, we won't play that sort of thing, but maybe with slightly fewer wrong notes. We can't play much else. We can start introducing our second note, which we're going to call beta, and that was, if this is 1, beta, remember, was 3 times that frequency. But because of the rule of octaves, we can say there's also one at 6, which is 3 times 2, double 3. And one at 12 as well, there would be. And there's also going to be one at 3 halves, half of 3, 1 and a half, sorry. And there's also going to be one at 3 quarters, half of that, and 3 eighths, and 3 sixteenths, so on. Okay, that's good. Now, you might be noticing at this point, I've certainly noticed, that this scale is a little bit all over the place. Like, we've got all the numbers bunching up there. We're never going to get to 0 because we're just dividing by stuff. And also at the top here, we've got stuff spread out massively. We're not using the space very well. What we need is a scale where, instead of adding numbers as you go across, you multiply numbers as you go across, right? So that, let's say, the distance between 1 and 2 will be the same as the distance between 2 and 4, or the distance between 1 and 10 would be the same as the distance between 10 and 100, right? Because you're multiplying by the same amount as you go along. That's called a logarithmic scale. So let's do that. Let's stick everything in logarithmic scale. Whoomph. There you go. And now you've got your frequencies. That's 1, that's 1 and a half, that's 2, that's 3, it's 4, that's 6 and 8 and so on, and all the other ones. You've got all these. Now they're all lined up nicely. You're never going to get to 0 at that end of the scale because we never need it. We're only going to be dividing by stuff. You're still going to go up high at that end, but everything's now going to be nicely the same distance apart. Okay. The other thing about this scale is, you might have noticed we've got 1 here, we've got 3 halves, which is 1 and a half here, and then we've got 2 there. And now 1 and a half isn't halfway between 1 and 2. That's because, again, you multiply by an amount to get a distance across. What do you multiply 1 by to get 1 and a half, or 1 and a half? If you multiply by 1 by 1 and a half by 1 and a half, you do not get 2. You get 2 and 2 and a quarter. So what would actually be halfway across this scale would be whatever number you have to multiply by itself to get 2, which is the square root of 2. So halfway exactly across this scale would be the square root of 2 times the first note, which of course is a rational number. Pythagoreans would have hated that. Also, if you went a third of the way across, that would be the cube root of 2, and the fourth one would be the fourth root of 2, and so on. Anyway, that's a logarithmic scale. So we've got our alphas and our betas. That's great. Beta was 3 times the frequency, or 3 times or divided by any power of 2. Okay. So in our octave now, we've got this stuff going on. Let's have a third letter. Let's have gamma, alpha, beta. What we're going to do with gamma then, we can't use other harmonics. We've run out of other ways. But what we can do is, right, so if this root's called the tonic or the This note's called the root or the tonic, sorry, which it often is. This one will be called the dominant. It's 3 times that frequency, or 3, whatever. What we can do is we can find the dominant of the dominant. This is alpha, this is beta. We're going to find gamma by looking at that. So if beta was 3 times the frequency, then gamma is going to be 3 times that frequency at 9. 9 times the frequency. Now, it's quite hard to hear what's going on there, but luckily we can do octaves. 9, 9 halves, 9 quarters, 9 eighths, 9 sixteenths, 9 30-seconds, 9 64ths, exact, etc. Right, so we've got alpha, we've got beta, and we've got gamma. We're getting somewhere, aren't we? This is fairly musical. This is not doing as badly. Okay, so that's not bad. I think this is okay. When we had just alpha and beta, we could do this. We could go, which at least we know is nice and musical. Now we've got alpha, beta, and gamma. We can do the beginning of Sound of Silence. We can't do any of the rest of it. We haven't got enough notes, but we can do the beginning of it. If we focus on this note up here at beta, we can also go. We can do what sounds like a sort of bass line, a backing thing. It's not a melody really yet, but it's notes that definitely go together. We're onto something. Alpha, beta, and gamma. We've also got beginning to get the tunings of various instruments. In fact, we already had one. If we used that note and that note twice for our 3 strings of an instrument, we'd have the tuning of a balalaika, or the relative tuning of a balalaika. And now with this one, if we used a gamma, a beta, and an alpha, and a gamma, and a beta, we'd have the tuning of dotara, which is a Punjabi instrument that I once had to tune and string one that someone brought into the guitar shop I worked in. Found out that this was a standard tuning for it. So we're definitely getting somewhere. What happens if we carry on? Alpha, beta, gamma at 9 somethingths. Well, we'll multiply by 3 again, so we're going up powers of 3, 1, 3, 9, 27. And we need to divide that by whatever we need to divide it by, whatever power of 2 we need to divide it by to get it into our octave between 1 and 2. So 27 over 2 or 4 or 8 or 16 in this case. 27 sixteenths. 1, 3 halves, 9 eighths, 27 sixteenths. And that is our delta note. And now we really are beginning to get some music going. Sounds pretty musical to me, doesn't it to you? Cool. Can we play anything? Well, no. Well, we can play a little bit. We can play the riff from... play that funky music, White Boy. Not that we can play the rest of the song, but we're getting to things that sound like music, right? We're getting to playing the things we can Sound of Silence, play that funky music, White Boy. Stuff's starting to happen. We also have, if we were to take an alpha and go up to the next beta, and go up to the next gamma, and go up to the next delta in that order, we'd have the open tunings of, or the relative open tunings of the strings of violins, violas, cellos, also tenor banjos and mandolins and all sorts of folk instruments. And if we were to do it the other way around, if we were to start on a low delta and then go delta, gamma, beta, alpha, you'd have the relative tunings of the bottom 4 strings of a guitar, the lowest 4 strings of a guitar, or all 4 strings of a bass guitar, or all 4 strings of a double bass or various other instruments like that. So we are definitely getting into the realms of tuning real instruments, and we're just using this principle where we're just taking the second harmonic, the dominant of every note. 1, 3 halves, 9 eighths, 27 sixteenths. What happens if we do a fifth one, 81. 27 times 3 is 81. 81 64ths gives us this pitch. Finally, we can do the rest of the play that funky music White Boy riff. We go. Right, play that. We can play all sorts of things like that. Oh, it's that solo that guitarist Lyres likes to solo over all the time. The pentatonic minor scale, which is the same set of notes just starting in a different place. Right, that's that Ridley solo that guitarists do constantly, over and over again, constantly, all the time, just that scale, all the time, over and over again, always without stopping. Guitarists always do it. But it's a good scale, that's why it works. The major version, which you will notice sounds exactly like black notes because it is the same set of notes that are black notes. This pentatonic scale is the black notes, effectively. Not exactly, because we're in slightly different tuning, but we'll talk about that in a minute. This as a major scale is such an intuitive and natural scale to sing. There's a video by Bobby McFerrin on YouTube, which I will link to under this one, which is brilliant, a brilliant exposition of exactly how natural it is. He gets an audience to basically sing it without apparently knowing it. And they anticipate and work out the next note in the scale without him having to tell them. It's a very natural scale. We've even got a chord here, a major chord, and a minor chord. Right, that's great. We can definitely do stuff with this. What happens if we keep going? Let's keep going. So now we go.
Ha 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 ha! I am evil Lord Zarkon of the Bogue Island. Sorry. Sorry.
I'm evil Lord Zarkon of the Bogoids. I'm evil, and I'm here to take over these music because I'm frozen here inside because I'm getting bored of all these good music lessons with good intentions. I want evil music lessons from now on. I'm going to be in charge of this. I'm going to zap anyone who doesn't like it or something. How do you feel about that? How are you going to get out of that? I see trap. I'm evil.